Okay. All right, everybody. I'm Paul. Most of you, I guess, probably have seen some videos or maybe been on these or talked to me before. We're doing a live Q&A, which is kind of more of a briefing on a new product that we're really excited to announce. We have Jim, which famous Jim here, the owner of the company. And then we have Brian, our guru of drying and our lead engineer. Existing customers, you probably have talked to all three of us or at least two of us. But yeah, let's kick it off. And, you know, we'll start with Jim and really what a lot of people have already asked and why are we building a non-vacuum dryer? What are we doing that for?
Right. So we've been in the vacuum dryer business for 40 something years now between, you know, my family and I, and it has always had its niche. And I think a lot of the customers can relate to this, that iDRY solved a lot of drying problems for several different wood niche products. And we did it, I think, pretty well and as simply as we could, and as low a entry price as we possibly could. But I've always told people that if you're getting into vacuum drying, it's usually for a niche product. It's for slabs, baseball bats, furniture squares, pool cues, guitar parts, other higher end furniture components, and maybe some flooring or something like that, cabinet parts and so on. But almost always a pretty high-end hardwood application. The urban wood business has certainly been a really perfect application for iDRY, for vacuum kilns, and the urban slab business specifically. So we really set out to solve those problems that weren't being solved already in the industry. And that's what we've been building products for. All along, though, we've always told people that if you're going to saw 4/4, dimensional oak, or you're cutting pine for an interior or even an exterior application, that probably you're not in the market for a vacuum kiln if that's all you're going to do. If you're going to do it a bit and you're also going to do some of these higher end applications, great. The vacuum kilns we build are going to work fine, and they're really versatile in that way. But if you have either your business is just 4/4, it's smaller dimensional lumber for hardwood or softwood, or maybe you have started with a niche business, drying slabs, but more and more you're trying to cater to a local hardwood or softwood dimensional market, 4/4, 5/4, 6/4, maybe 8/4. You've probably found that the iDRY vacuum kiln is tied up drying a much more profitable product like walnut slabs or something. And who in their right mind is going to pull those walnut slabs out of there to dry some 4/4 ash or oak or whatever? It doesn't make any sense. The margins just aren't there. So the alternatives, the ways people have gotten that done, is either just air dry it and sell it air dried, try and sneak it into their vacuum kiln when they have time, send it somewhere else. We have customers who have multiple vacuum kilns but still send a truckload of 4/4 to a conventional kiln operation because it just doesn't make sense to tie up their vacuum kiln. You buy a DH kiln, you build yourself a kiln, solar kiln. If you go online and you follow some of these forums and Facebook pages and so on with people and kilns, you'll see every single kind of shape kiln you could possibly put together to try and get some of this wood dry. And like it happened for me years ago, I started to get sick of saying, sorry, we can't help you with a simple, less expensive kiln for drying those higher volume but lower margin products. And so that's where the iDRY AIR idea was born. And the concept here is that we can have essentially the guts of the kiln, right? It's the business end of the kiln. In fact, it's really inspired by the business end or the busy end, the hot section, whatever you want to call it, of the current iDRY products, where you have the fan, the heaters, the controls, where most of the work is done in our process. The rest of the machine we sell today is a stainless steel vacuum chamber. So imagine removing the stainless steel vacuum chamber piece of it. If you don't need a vacuum pump, if you don't have a vacuum, that component, which is expensive and heavy duty, isn't entirely necessary. We also wanted to have something smaller we can ship more easily, and that would allow customers to make up their own chamber. Maybe everybody's got a different idea of how that could be done. You could stick build something and insulate it. Shipping containers have certainly been done an awful lot. So how could we make a product that gave you the hard part, the difficult, challenging part of the kiln, which is how to have proper airflow, proper heating, proper venting, and most importantly, proper control over that process. And then make it simple so that any of us can use it with any wood we want to load in there, just like the iDRYs are designed to do now. Load it, softwood, hardwood, press start, and get good results without having to become a kiln operator, follow recipes and kiln schedules, and basically be constantly developing a process when you should just be drying wood and making money and maybe cutting wood. And so that's what we set out to do some time ago. We built the prototype, we've tested it, tried all sorts of different things, built our own chamber very simply, very, very inexpensively, attached the iDRY AIR to it, and it's already proven itself to be incredibly efficient, very simple, very effective. We're getting high quality lumber out of it. It's sitting in our factory here next to piles of iDRY standards and pluses that are going out the door all the time. And it's clear already to us that it is going to meet a need that the other kilns are producing are not meeting. So we're really excited about it. I'm sure everybody has a lot of questions about it. I think we'd really like to let Brian say a couple of technical pieces that he's learned along the development process, and then open up for some questions, and Paul can kind of field some of those questions. So Brian, tell us some of your thoughts and inspiration on this.
So I'm going to start by addressing the gorilla in the room. This is not a DH kiln. We are not a dehumidifier, right?
Vacuum kiln.
Yeah, but what does every kiln have in common? A DH kiln, solar kiln, this kiln. They all have airflow, they all have heat, and they all have venting. That's it. Every kiln are doing those three things, all in slightly different ways, and some combination and pros and cons of all those three things. And so, but that's it. You break it down to the airflow, heat, and venting. And so a DH kiln, has a fan deck and fans, and the compressor is doing the venting, but it's also a DH kiln is kind of combining heating and venting kind of at the same time, and that is its pros and cons. There might be times when you don't want to vent and you only want to maintain heat, so there's some complications there. And then so every kiln has, with those three things, every kiln has a pro and con list of how they do those different things, right? So we've known and learned a lot about airflow over the years. I mean, heck, we've been trying to do airflow in a vacuum. I mean, that's not an easy task to do. We have just enough air, and we've got to be really good and efficient at moving that air to use it. So we've always known quite a bit about airflow, and recently with this project, we've done a bunch of airflow studies and different things with the airflow. Heating, I guess a lot of people would consider that dry bulb, but just heating the wood or the air, that's pretty straightforward. But how efficient you are at that, or then there's some things related to heating, but that's kind of the easiest, low hanging fruit. But I think the biggest overlooked part of those three things is the venting. Nobody's doing venting properly. They're either always venting, they're not venting. A DH kiln is trying to vent and heat, and then so it's kind of fighting itself in a way, and maybe that's good in the beginning, but later on it's not. Solar kiln and venting, maybe some guys are opening and closing a vent sometimes, or even when they are automated. Venting is pretty overlooked, and I think it may be one of the most important things. So by venting, that's the humidity in your chamber, right? So the humidity, you're trying to balance what your humidity is to still do some drying, right? You don't want to be so humid that the wood can't dry, but you don't want to be drying too fast, and that would be, it's not humid enough. You want to be able to. We talk about conditioning a lot, right? We want to be able to have the wood happy and the surface, the shell, moist and conditioned enough so that it doesn't over dry, but we still want to promote a drying, situation. So that's a tricky balance to do. So, and that's where all your defects come in, right? If your humidity's not right, ultimately that's really where you over dry this. That's really how you are over drying the surface, and have your defects, your surface checks and cracks and cupping and splitting and all that stuff. Most of it is due to the venting and the humidity. And when I say humidity, a lot of guys will also talk about. I mentioned heating and dry bulb. Well, people talk about wet bulb, but wet bulb is a representation of humidity, right? And wet bulb is just an archaic way of measuring humidity. So I'm not gonna talk wet bulb. I'm going to talk humidity. There's fantastic humidity sensors out today. We don't need to be putting a wet sock on a temperature sensor to do that. A good humidity sensor is going to give you great information and last for a really long time without having to run out of water for your sock for your wet bulb. So wet bulbs are dead to me. So anyway, so I'm talking humidity and venting. We're talking dry bulb, and I'll say dry bulb, but we're talking heating, and we're talking airflow. And we also want to do all those things really efficiently, right? We want to be energy conscious when we're doing all of these three things, right? You don't want to be heating. Obviously we're going to be turning on and off the heat, but we want to be conscious of the energy consumption of doing all of those things. And so we've actually found the airflow has a lot more value than I think anybody has really thought. We've been working on the airflow part of it as part of the humidity or venting control. So to maintain this humidity, we're either venting or we're adjusting the airflow. And so those two combinations, we're maintaining humidity in a couple of different ways. The other thing with airflow, airflow is the mechanism in which we're moving the heat, or moving the BTUs, the heat, the energy, to the wood. And there are times when you don't, you don't need as much energy. You don't need as much moving of the heat, and you don't need as much airflow. And so in adjusting your airflow, if I lower my fan speed and lower my airflow, I'm conserving energy, and not just by the amount of reducing the speed of it, but by some square factor. You reduce your fan speed by just 10% and you're saving like 40% of your energy cost. So there's a big value in adjusting our airflow. And the other part of that is we have the airflow, the heating, and the venting to do a really wide range spectrum of applications, right? So what do I mean by that? We have enough airflow to do some of the species that want really high airflow, but then we have the ability to slow down that airflow. So there's some species that we only need half that airflow. So we're drying red oak. Red oak doesn't want the same airflow as white pine, but we have the ability to do both. We don't need as much venting with red oak as we do with white pine, but we have the ability to do both, and not just in a limiting of board foot capacity. So we're gonna maintain the same board footage for sopping wet pine versus some other red oak species. So we're not going to derate the system by some board footage because we can't handle the moisture or the capacity of the volume. We're going to give you a kiln that can do large capacity, high water content, but then can be automatically adjusted really to do other species that don't need those parameters. So we're really covering huge. It's a big task to do something that a huge spectrum, but do it all well. And so that's where we're really making sure that we can do all of these things.
Like for instance, a traditional conventional red oak kiln really can't dry 4/4 maple. It was designed with fan motor horsepower, airflow, heating, venting, everything to dry a species that we need to slow down in its drying process, or there's degrade. So you can't just put a faster drying species like maple that needs to be dried fast to maintain its color in a red oak kiln. So like Brian's saying, it was a challenge to design a kiln that can do this broad spectrum, soaking wet eastern white pine, keeping it white, bright, dry it properly, or red oak, which dries pretty much the opposite. It's really good.
Right. And Jim touched on this earlier, right? So what is this iDRY Air good for? It's it's a kiln that is really going to be good for these low value species, right? So you've got an iDRY and it costs you a boatload of money and it's working great, you can make a really good profit on some high dollar species, walnuts and other hardwoods, but you're really going to struggle to, you as a company with a kiln, you're really going to struggle to make a profit or make your money back on an iDRY with pine, red oak, and firewood. I mean, there's people that are putting firewood. It comes out great. I mean, it dries firewood in a reasonable amount of time, but you can't sell the firewood, the value in the firewood for what you could have had in it, with some of those higher value species. So this is in one big way, this is a huge complement to guys that already have an iDRY, an iDRY Plus. You have an iDRY and one of these air units, and now you're banging out 4/4 yellow pine and firewood while you're doing some walnut slabs, and man, that is a good business. It's very economical, cost effective, really good for our existing customers, but it's going to be amazing for guys we haven't touched yet, guys we don't know, the guys that couldn't justify buying an iDRY because they're doing too much pine or they couldn't afford it or whatever. So this big undertaking was we were really thinking about what can we give you guys for your toolbox, how can we make you guys more successful? And this was a a hole that we thought we needed to fill, for our customers and other customers, future customers.
Yep, perfect.
Cool.
And we try to make it so darn simple that we can send it out to any of you. You can take a 20-foot or 40-foot shipping container, build your own shed or whatever box you want to make, and with really reasonable expectations for that chamber, bolt this thing on the side of it, plug it into some 220-volt single-phase power, and be in the drying business for a lot less than basically any other method. And that was also a big challenge. How can we make it really easy for you to install this, to receive it, and then put it into service and have it work and have it be reliable and so on.
Right. So it's a self-contained, part of the kiln, but you as the customer, you're going to need the container, the shed, the structure, which this just bolts up to. But you don't need to wire anything else to this structure. No fan decks. You don't need to add any other sensors or vent kits. Or our little box, it has all of that in there, which is just bolted on to whatever room you can put your wood in. Which
could be outside, could be in your yard.
Yeah. And
Yep.
And we're
There's
going to
a couple of questions, Brian, not to interrupt, but
absolutely.
James Holman was asking one about the dimensions for if we want to build his own 4,000 board foot chamber.
Yep.
Out there, we built about a 2,000 board foot chamber.
Yeah, a little bigger than a iDRY standard.
Standard, right? So if we wanted something more like an iDRY plus, about 4,000 board feet. Yeah. What would we recommend for a chamber size dimensions, length, width, height? I know there's some flexibility there, but.
Sure. I mean, if right now, I think we have on the drawing board something very similar dimensionally to the plus.
Yeah.
The length, the width, the height. So that
which would be like 60.5 feet usable length by 5 feet by 5 feet would be the lumber pile dimension. Exactly. And then add a foot on either side of that pile for plenum space for airflow. Yep. So maybe you have something that's like, outside dimensions of 8 by 8 by, less than 20, 8 by 8 by 18 or something would be the outside dimensions of a box. Yeah. We tell them a little bit about how we built our first chamber. We were aiming to try and build it as cheaply and simply as possible, right? It's inside of our building, first of all, so it's not trying to hold, we still have some snow, but we're not getting snow right now here in Vermont, but it's not meant to hold any snow. It's not meant to be out in the environment really, but it was really simple and cheap. So, and how did we do that?
Well, I told the guys, I want you to make a chamber the size of a standard, maybe a little, maybe, and actually longer, or more of our standard extra long. Make that chamber size out of 2x4s and some insulation board.
That's it. Two materials.
And here's your $500 budget or whatever it was.
Right. I think it came out to $1,000 for the whole entire chamber.
Yeah. They built it. They got the 2x4s and built it in a day.
Yeah. Done.
we bolted the air unit on, and we were drying that same day.
Exactly.
Yeah.
That's what we're shooting for.
Yeah.
So there's Damon Barron has a question, and then there's another one behind that. For drying schedules, Damon's question is there some sort of drying schedules that is programmed the variation of species and thickness? So we've been around and around on that, but I think our position right now is what, Brian, like softwood, hardwood, start?
Yeah. So because there's a big enough difference on how we want the kiln to operate in this automatic mode, there's a big difference between this, the soft, the pine you want to dry and the red oak, right? So there's too big of a spectrum for us to say, just run your automatic schedule no matter
One
what you
mode.
do, right? So you're gonna say I'm doing softwood or hardwood, and then what we've learned, really, I mentioned it before, that the humidity is so important in this kiln. If you're maintaining the right humidity, chances are you're drying properly. I mean,
Yep.
it's kind of that simple. And so and if you look at every schedule, if you look at the conventional kilns handbook and the DH schedules, and they use the wet bulb. But if you just do the conversion, right? There's wet bulb to humidity. If you plugged in your humidity numbers, it's kind of stupidly simple in a weird way when you look at it. It's maintain enough humidity, but not too much, and then as the wood is drying, try and still maintain some level of humidity. But ultimately your humidity is gonna start to plummet and drop off, and then the game is just not to let it get too dry. Now, as the wood gets drier, the only reason why it's humid in that box is from the wood water, right? The wood's water itself. So that's huge feedback. If we're watching the humidity, I mean, which we've been doing in the iDRY for forever. Guys can't live without it, right? So it's how we don't have schedules in the iDRY, regular iDRYs, because the vacuum allows us to get away with a few things. But guys are watching that humidity, and when that humidity drops to a certain point, they know their wood's starting to get pretty dry, and they can go in and look at it or make some adjustments. Most of our customers are using the humidity levels to decide whether they go from high power to from low power to high power, right? Raise the temperature based on the humidity. Right. So we're really doing the same things. We're looking at the humidity. We're really maintaining these humidities in the beginning, or not too much, right? We're venting. We're going to control humidity, right? So if it's softwood, we're probably going to be doing more venting than not, because we have a lot of water to get rid of. But we're still maintaining a humidity. Red or harder woods, we're still maintaining humidity, but probably venting less. And then now, as the wood gets drier, we start to see that, and we're gonna try to keep a level of humidity, but then start to ratchet up the temperature, a bit automatically, right? So rather conservative.
As the wood dries, the temperature goes up.
I mean, right. So at some point you need to start raising the temperature. And if you raise the temperature too soon, that you'll start to get yourself into trouble. But too soon is definitely a feedback from humidity, right? If you're really humid, you're not raising the temperature.
Right.
So
why would you do that?
Yeah. So we've got, the software we're working on is doing the humidity control. It's going to start to decide when to ratchet up the temperature
and control the fan speed.
Well, I was going to get to that.
Sorry to interrupt you.
Well, no, I mentioned that a little bit earlier in being efficient with the airflow. Use what you need. But the airflow can be adjusted, is adjustable based on the humidity feedback. That airflow is helping us maintain some of the humidity. And
it's also reversible, right? And
that's
right.
I can't believe kilns out there are not reversing airflow, and they're not reversing airflow because their hands are tied. They can't. You have a DH kiln, only works in one airflow direction, and there are other kilns that, because they're venting, you don't want to vent the hot air you just produced, right? So you always want to try to vent the cooler, moisture air. Well, depending on how your kiln is configured, you don't have the availability to reverse your airflow. And so, but that's kind of huge. How are you always flowing across your pile of wood, the hot air across this side of the wood, and cooler, wetter air on the other side of your pile of wood? Always. That can't be efficient.
Even drying. There's no way.
And to dry, that just boggles my mind that is okay to do. So we always wanted, and we always have reversed reverse the airflow because our design allowed us to do that. And so we
Right.
we knew that that was something we wanted to stay with. So by reversing the airflow, sometimes we're heating the other side of the wood and then passing that moisture to the other side of the wood and conditioning it better, and then reverse the airflow. You're heating now this side and conditioning that side better. That alternating airflow dries evenly and I would argue faster.
Yeah, for sure.
We got a couple other quick
a couple of
questions
questions
here.
Yeah.
Does a shipping container need to be insulated?
Yes.
Yes. You want to, I mean, if you don't insulate, you're just going to be losing all your heat. And so you just,
and potentially condensing moisture that humidity
Sure.
faster than we'd like to. So yeah,
you want to do, yeah. Go ahead, Paul.
Absolutely. So insulate the chamber. And also, does the stack in the chamber need to be baffled to direct airflow? We want to baffle just like we do in our standard kilns.
Just like we baffle every kiln. You baffle every
kiln,
right?
Yep.
Any kiln. You want to be effective in your heat, which is insulation, and you want to be effective in your airflow, which is baffling. I mean, that's just common practice for every
and it's also super simple, right? If your lumber
yeah.
stack is this long and your kiln is this long, you can literally just put a piece of insulation on the end of your stack. The way our airflow works horizontally,
anything. I mean,
it's
we're
super
come
easy.
Up, yeah, I mean, there's so many different ways to baffle. I mean, maybe we come up with some ideas in our handbook and baffling, but
it's just very simple.
I mean, everybody, is.
But very important. You got to have air going through.
Yeah. You want to do that and to be efficient and effective.
Yep. So Zach asked about whether we meet the USDA's heat treat sterilization requirements, which we absolutely do.
Oh, hell yeah.
Yeah. Over 60 Celsius for 60 minutes at the core, right, is the rule. But we are going to way exceed that. So if assuming you dry wood in this kiln to the end, right? So it's gone through the whole cycle, you'll easily exceed that.
We're gonna have enough force. One of our targets is to do firewood really well.
Yeah,
so we're gonna have enough horsepower to do firewood, which is high heat, high venting. And so, no problem.
Eric asked if the chamber's indoors, do we recommend venting to the outdoors?
Right.
Probably not a bad idea. Maybe depend. I mean, we're venting technically to the inside of our building, but we have a big, gigantic,
huge building
factory, right? Probably not a bad idea. Maybe depends on the size iDRY AIR that you build, because keep in mind, right, we're selling you this box, this kiln box that has the fans, heating, controls, and whatever that bolts onto your box. If you want a 20-foot long, say 20-foot shipping container kind of size kiln, you take one iDRY AIR and bolt it on the side of it. Something we haven't talked about is if you had a 40-foot shipping container kind of size box, you would bolt another iDRY on the other end of it, and now the airflow is moving together this way. So you actually have double the capacity, and you have two iDRY AIRs, which are just simply these fan heating modules that bolt on. And so if you're drying just one iDRY AIR and maybe a 2,000 board foot chamber, and you have a pretty big building and you're not super worried about humidity, maybe you get away with venting to the inside of the space because it's not an enormous amount of moisture. It would be incredibly easy to duct it out if you wanted to. But if you're drying with a much bigger chamber, you're drying 8,000 or 10,000 board feet at a time, which a couple of iDRY AIRs would be capable of, you're definitely going to want to vent that moisture out. It's just going to be a lot of water.
And our ducting is going to be like a clothes dryer, really.
Wow. Yeah, exactly. Imagine ducting out a clothes dryer.
It's a 6-inch ducting.
And Dave asked, does it matter? Does the external humidity of your environment matter? So if you're in Alabama in the summertime, or if you're in Alaska in the wintertime, does that make much of a difference? I would say it always makes some difference, but I bet you'd have a hard time measuring it. We thought about this early on in the design engineering process, like how much does the external environment matter to this unit, assuming everything is insulated properly. I think it has very little effect actually, because if you imagine inside this box is sort of like a hot, messy hurricane,
Right.
and nothing compared to this very slight, small variations in humidity and
And
temperature you have outside.
I have an example for that, Jim. I
Yeah.
asked the same question, Dave, and I actually sat down with Laura, one of our engineers, and
Yep.
really the humidity changes drastically with warmer temperatures. So if you're at 90 degrees, 90% relative humidity, once that air goes into that box, and say the box is at 115 to 120 degrees, relative humidity drops down to like 45%.
Yeah.
We did the math.
Because it's relative to temperature.
Correct.
But it's
Temperature
also-
changes it. So
But it's
Exactly.
also the same problem that solar kilns have and DH kilns have, and
Yep.
we're still doing the same. We're going to be still similar in the effect that those have. We can't overcome that. So it's all of those kilns have a performance effect to that stuff, but it's minimal, right?
Yep.
Scope. Yeah.
So Lance, one of our customers, was asking about what do we do with this iDRY Air box? And yes, it is designed to be bolted on the end of your chamber, whether that's a shipping container or a chamber that you've constructed yourself, 2x4s insulation or whatever. It bolts on the end of it. And you're right, Lance, similar to the typical iDRYs, you've got your lumber pile, the air is flowing out of this through the pile and then down the other side of the pile. So it's flowing around in a circle horizontally and then reversing and going the other direction. So unlike you bring up a Nile kiln or a lot of conventional kilns, which typically have a fan bank on top, motors mounted up there, and then the airflow is flowing down through the pile of wood and then back, and then a lot of times not reversing.
Right.
So
well, in most cases,
so our airflow is still the same. It's really, imagine like an iDRY standard or iDRY plus minus the vacuum part, and therefore not requiring the chamber part, which is not going to perform the same way as a vacuum, but it's going to do darn well, be on a totally different price point, be really, really simple to operate and to install. But the airflow pattern is the same. I did say something, Lance, that I want to make sure you hear is this is designed to be modular and expandable. So if you want one iDRY Air and let's say 20-foot shipping container, you could do that, right? It would look really similar to a plus, let's say. But you could have a 40-foot shipping container and just simply add another iDRY Air on the other end of that container. And the airflows out of each of those units would be opposite. They would flow towards each other down one side of the pile, pressurizing that side, flowing through and then back again. So you have these kind of counter air flowing directions, and then of course reversing. And then if you wanted to get really crazy and even need 20,000 board foot capacity, you could do that double high and have 4 iDRY Airs.
Right.
And at 19 grand a pop plus your chambers, you could end up with a 20,000 board foot kiln for a fraction of the cost of building a conventional kiln or a DH kiln.
A 20,000 board foot cost
conventional kiln, essentially an unconventional conventional kiln, for like half price.
Right.
And using chambers that you can build yourselves or ship containers that you just insulate.
Yeah.
So Dave asked if 2 units would speed the drying. Like if you have say you stick with a 20-foot container, you put 2 on, you're not going to see a noticeable difference. Dave, in fact, the goal is not to dry too fast, right?
Right.
So
exactly.
more is not necessarily better.
Slow. Well, by our standards, we're saying we're going to dry, slow. But we think it's going to be faster than some other ways to do it. But it's still this is a slow drying system.
Yes, it is not a vacuum kiln speed, but it's so far very much faster than a DH kiln or typical conventional kiln. But the goal is actually really to more match that performance, just do it in a more simple, cost-effective way. But we're not looking we can't double it up and just increase the speed.
Sure.
So good question. Jeff asked, when are these suckers available? And, you know, what's the life cycle expectancy for a unit and so on. So I'll address the life cycle piece first. It's a little bit easier. Like all of the products we build, we're trying to build them to last forever, right? So stainless steel, best motors, best fans, best controls, best overall materials for construction. So corrosion resistant, rugged, dependable, etc. The availability is a little uncertain right now. We're currently we're anticipating selling a lot of these, so we need to finish the stage we're at. We're going to be producing a few beta units for existing customers to test. You know, this is going to be the next few months that we do this, and then based on our waiting list for them, which by the way, we are going to be taking little $100 deposits and starting to create a waiting list so that when it's ready to ship, you're not 100th in line or whatever. But my personal goal, being the captain of the ship, would be in the fall we start shipping them. You know, it's subject to a couple of things, but I feel pretty good that by the end of the year we're starting to pump these out. Jason wants me to take his money. I'll take your money.
We got James Holman asking a quick question. Do you still recommend air drying all species before putting it in this kiln, or just certain species such as red, white oak, and walnut, etc.? Well, Brian's got some exciting news for you.
I'm drying red oak from green, and it's awesome.
Now it's 4/4 red oak from green, right?
Well, yeah, sure.
Yeah. 4/4 red oak from green.
No, it's not slabs. You know, you do have to, you know. So we're saying we want to do these low value species, and they're red oak, firewood,
low
pine.
Margins. Let's call them. It could be FAS 4/4, whatever,
sure.
right? Beautiful, perfect wood, but the margins practically are less.
It's for us. This is where you're going to be really cost effective, but you certainly can put anything in there you want. And so that's, you know, the similar best practices for other kilns are going to apply. Now we're maybe going to be better at doing you know, certain species and in quality and time. And you know, we're not going to put any limitations on it. You can't put it, you know, don't put something in, but we're going to, so much like some other kilns, they have some schedules. We're going to give you some guidelines on, and some best practices. You know, they'll, you know, we will have a full user manual, and we'll do the best we can to set you up for success. But anytime you can air dry and take the pressure off your kiln, I mean, that's never a bad thing, because you're unless your air drying is causing you some damage. You know, there are situations where you do bad job of air drying, and so, you know, we certainly can talk about it. But I'm doing from green, red oak from green, pine, you know, sopping wet pine from green. You know, those are the things that right now in our prototype that we've been just churning through, and it's all coming out great.
Red oak was a focus
we
of
have
ours
done,
in the beginning, right?
and we have done maple. Yeah, we've done regular maple, and no problems there.
Well, we've said forever, right, that red oak is a challenge, and it is a challenging species to dry. It is the reason we've really pushed back on it as an application for the vacuum kilns is a couple of things. One, it's a lower margin product. Two, it's hard to dry, and you could be drying something that's higher value, easier to dry in the vacuum kiln that it does better. One of the things that we set out to do with this kiln is to dry red oak, 4/4 red oak from green, and we're doing that. And the motivation for us is that we know that 4/4 red oak represents the vast majority of the wood that is dried in our country is 4/4 red oak, like by a long shot. There's like that much 4-quarter red oak that's right in our country. There's that much everything else for hardwood. That's just hardwood. So we really wanted to finally solve that problem, and give you a practical, cost-effective solution so you could make money drying 4-quarter red oak, whereas otherwise you couldn't.
And
let me just,
Brian,
well, let me
talk
just,
about the,
I just saw the question about
power.
the
Good
power.
question.
So I thought it's a good time to bring that up. So, we talked about the things that we're doing to be very efficient with our power usage. I just got in the office some kilowatt monitoring hardware, so I'm going to be doing a detailed study. But it looks like we're in the 1 to 2 kilowatts per hour. We might be a kilowatt
iDRY unit, AIR unit.
Right, for the iDRY AIR, yeah. So for operation, it's about let's say for now until I measure it, a kilowatt and a half an hour. So
which is incredibly
crazy.
inexpensive.
That's pretty good. And I think it's going to be less, but let's say 1 to 2 for now. Obviously, if you're doing firewood, maybe it jumps up to 2. If you're doing red oak, maybe it's 1. I mean, it's going to be
exactly. Oak would take. That's a good point. Oak's going to take less power because we need to dry it slower and go easier or whatever. What sopping wet pine would take more energy and therefore use for more kilowatt. But we're not talking about a huge amount of energy either way.
No.
And really of course, efficient process.
I'm sure. Yeah, and with that, I haven't seen the question, but then how long does it take to do that?
Right.
I mean,
that's a good question.
Right. So a typical schedule for green red oak, is at least 4 weeks. And so I've done it in less, but we're going to stay with it's going to take a month, for something like that. But so so if you say 4 weeks at that kilowatt usage, you could come up with what your costs are. But we're gonna do this kilowatt study. We're gonna release that information. I did see another question about more pictures and videos. I have several videos in the works. I've got a video, operation and principles. How does this work? So I have a video about to be released on its the functionality of the thing, and then we'll be doing videos on here it is more in action, some more in action videos. So all of that is coming very quickly. So we'll be churning out this data and information to pass around soon.
Great.
Cool.
Paul, did you see any other questions in there that we?
We got to wrap it up.
No other questions. I just wanted to. So everybody on this chat right now, everybody who signed up for this event, we're going to get a deposit link out to everybody. It's going to be a real small deposit to get on a list. Like Jim said, we're going to build up the waiting list, so you aren't going to be 100th in line by the time you decide you want to do it. So we'll get that out to everybody. And I guess one last question: how much does the unit weigh? I don't know.
No, I think we figured.
Lauren has that somewhere.
Yeah, Lauren has that information. We can get back to you on Brian a more precise number, but it's in like the hundreds of pounds, or
it's not
nothing.
It's
crazy.
not outrageous. It is meant to be bolted up on the side of a chamber and be self-supported that way.
And shipping it to you, it'll be on a pallet, right? Wrapped.
Really simple.
And you unwrap it from the pallet and
Mark says less than 1,000 pounds, so we can get it.
And the deposit link was just dropped in the chat, so everybody who wants in and is excited about this can jump on there and put their $100 down. We're very excited about it.
Somebody said they want to give us $200 to be more up front line. So
it's funny. All of our employees in our facility are lining up.
They all want to get one.
They all want to get one. I want to get one. Cool. I'm going to do firewood in my backyard. It'd be awesome.
Right.
Anyways.
It's cool. We're very excited about it. Thanks everybody for taking the time today to participate in this. We love all of you customers and really excited to work with you new prospects. It's super fun for us. We just love it.
Yeah. we got a lot more to come, and we're
Yep.
very excited. So
Yeah, we'll stay
Thanks,
in
everyone.
touch. And, yep,
Super.
all good.
okay.